Welcome to SolidCAM Professor on our series of Getting Started. I'm Sydney, a SolidCAM Professor, and in this lesson we'll be showing you the use of 2.5D milling both the top side and the flip side of this particular part. We'll be starting with our first part, 2.5D milling 1. Now, since of one of my previous lessons, we've gone into depth of creating a part including the home position. I'll go through this quickly by simply going to New Milling, and I'll create my new milling part. I'll continue by creating my first home position, and my first home position will be on this side, since I want to start by milling this face, these areas around here, these slots over here. And I also want to create another home position, add another home position to mill out my second side over here. So I'll simply create another home position. I'll accept it. And of course I do want to create my stock, so I'll go into stock and create a box automatically around the part, and I'll give it excess of 2 millimeters on the side, and my Z plus excess material will be let's say 0.5 millimeters. I'll do the same thing on the other side too, and I'll also define my target by simply going into Target, Define, and we're just about set to start our operations by simply accepting this. The first operation I'd like to do on this part is to mill the face, the top face of this part. We'll start off by going into Operations, Add Operations, and choose Face. This operation is specifically meant for milling faces of any part. Now there are two particular ways which we can face mill this part that we see over here. If we want, we can take a regular face mill that's bigger than this area over here and do one pass over the entire part. That's one option. But there are many times when you're faced with a problem where you may not have that particular tool, and you may have just a regular end mill, say 20 millimeters. So there are different ways of doing it, such as going across, back and forth on the face itself until you cover the entire part. We'll use a second example for this particular part. Choosing my geometry is simple. Simply going to Define. And since I'm doing the entire model, I'll simply choose Model, Define, and click on the model. When I accept that, you'll note that there's a boundary that's being formed around the entire model. This is the entire face which I want to do a face mill operation on. I'll accept this geometry, and in my next operation, my next part, I need to choose a tool. When I go into Select, my tool table is empty. I'll simply create a new tool by going to Add, and I'll be adding an end mill that's in a millimeter dimension. I have the option of choosing millimeter of inch or inch, and I'll be choosing millimeter. And I'll say that my diameter of the tool is 20 millimeters. We have lengths, which I will not deal with right now, but these are the lengths I would like to have on the tool itself. My default tool data, such as my feet and speeds, I can set them at, say for example, spin rate of 5,000, and my feed rate, I can have that at say 800. This can be set at 400. This can also be set at 800. Now my levels, my upper level since I'll be starting on my stock material, I'll say my upper level is 2 millimeters. On my face depth, if I click on the button, I'll simply click on the face, and you'll note that I'll be going down 2 millimeters from my face. Now, in my technology area, we have different technologies of how we can actually cut the part. As I said before, we can do one pass, as you can see in the picture on the bottom left-hand side, if my tool was wide enough to cover the entire part. Since my tool in this particular case is not wide enough, I can either choose contour, going in and around, but my better choice for this particular case with such a tool would be hatch. As you can see, I will be going back and forth on the part itself. Now, in my data field, I can choose the angle that I want to use, or I can say do it automatically according to the best possible, most efficient angle needed for this part. My extension, I can have it extend past the part. If I were to choose 110%, that means that the tool will be actually 110% past the part itself. If I were to change this to 50%, then the center of the tool will come exactly up until the border of the part. In this particular case, I would prefer 110, as that would allow the tool to actually leave the part itself and then go back around. Now, we also have how much do I want to go past the part on the side. I can have it either in percentage. Over here, I can also have it either in percentage or in value, as an actual value of the tool itself. In this particular case, I prefer using percentage. And I'll say I want to have it at 25% of the tool going past the part itself. Now I can go either zigzag, back and forth, or in one direction. We'll choose the option of zigzag, and my corners, I can have them fillet also. This is particularly good, especially when you're working with higher feeds. I'll say OK. And in the overlap area, this decides what's the overlap between each tool pass. We can leave it at 30% of the tool of overlap, or if I want, I can even make it at a smaller overlap, say 5% of the tool. My next option, I have offset. How much do I want to leave off the floor? I can say I want to leave, let's say, 0.2 millimeters off the floor. And if I want, I can go back and say, after leaving 0.2 millimeters off the floor, I also want to do a finish cut. Let's simply do now save and calculate. And if I were to do my simulation, you'll note my tool pass will go back and forth along the part itself. I can also change the color of my simulation if that's not good enough for me. And I can also show the tool. Let's take a top view of the simulation in this particular case, and you'll see I'll do it one step at a time. The tool goes down, around, and as you note, it's past 25% of the tool part itself down the sides. There's a 5% overlap between the tool paths, and the tool leaves the part itself, because I wrote down 110%. If I would have done 50%, then the center of the tool would have gone over here only. In my next operation, I'd like to do a profile operation, going around and milling out this step over here. We'll simply do that by starting our operations, add operations, and adding a profile operation. I'll choose my geometry by going into define, and I'll choose a chain going around the part. I'll simply click on this line over there, and say auto constant Z, creating a geometry automatically along that particular line. Constant chain on that level Z. I'll accept this. This is my first geometry that I've created. Next thing I have to do is create a tool. Now I've taken the liberty of already creating an entire tool list, and I'll choose a tool that's 16 millimeters in diameter. Now my next step, I will go into my levels area and choose my upper level as the top of the part itself, which is 0, and the profile depth will be up until the step over here, in this particular case 5 millimeters, and note that this is automatically this value is automatically put into this field. In my next area, my technology area, I can choose to work either on my left side or my right side. I can choose to work either with compensation or without compensation. I'll be doing my depth type as constant, and I'll be going one way as I'm going down on the part itself. Now, when I do my rough cut, I'll be using a wall offset of 0.3 millimeters and a floor offset of 0.1 millimeters. I decided to go down every 3.5 millimeters. And with this particular tool, I can also do a finish cut. So I'll be choosing also to do finish. And I'll be doing it with one pass. And my step down, I can leave this at 0 since I'll be doing it all in one step down for my finish cut. Now we also have something here called clear offset. In my clear offset, I can actually start further away from my wall and then work my way in. Now I'll choose my offset, my clear offset, as being 4 millimeters. In other words, my first cut to be 4 millimeters away from the wall itself. And then my step over, how much should I go in every single time? I'll go in every 2 millimeters. And I can either go either zigzag back and forth or one way. In this particular case, I choose to go one way. Now in my link area, I can choose my lead in, whether I want to go normal into the part, note the picture on the side, or going in with an arc value, or a tangent. In this particular case, I would choose the arc, and I'd like to go in from a value of 2 millimeters, and my lead out will be the same as my lead in. And I could simply do that by just clicking on same as lead in. If I were to do save and calculate, and we were to do our simulation, note if I go from the top view, my tool, if I do one step at a time, will work. And notice it clears off this area over here. Now it works further in until it goes just before the step. And then it finishes off the part itself. Now if I want, I can also do the simulation using SolidVerify. And SolidVerify will see the exact simulation as how the part will look on the machine itself. The tool will go down. I can slow this down over here and just let it run all the way through. And as you can see, the entire part is being machined. Now, in many cases, you may prefer to go in the opposite direction. This can simply be changed, where if we go into our technology area, instead of choosing right, we can choose left, or we can go into our geometry modify area, and I can say, okay, let's choose our chain. Let's reverse our chain, and then say go onto our left side. If I were to do this and then do save and calculate, and then do simulate, again we'll use the solid verify simulation. This time we'll be going in the opposite direction. We'll now end our simulation and start our next operation. In my next operation, I like to mill now the very outside of the part itself. This wall around here, around the entire part. Again, I'll choose my new operation, again profile, and this time my geometry will be this particular line here. Now if I want, I could already reverse the direction by simply saying reverse, and now do auto constant Z and say yes. Now my tool that I will be using this time will be the exact same tool that I used in my last operation. I'll be choosing tool number 2, 60mm end mill. My levels will be as follows. Since I've already milled down up until this level here, I'll simply click that as my upper level. And my profile depth will be until the very bottom of the part, for a total of 5mm in depth from the upper level. In my technology area, I'll be working this time on the left. I can use compensation or not use compensation. And since I'll be using the exact same tool I did last time, which if remembered correctly, I was able to do for both rough and for finish, I'll choose rough with a wall offset of 0.2mm. Since I'm going down all the way on the outside, I do not need a floor offset. And my finish, I'll also be going down in one step. Now my step down in my rough, I can have it at 3mm. And my finish, I'll leave this at 0 since I'm going down all the way to the very bottom. Now, my link, in my lead-in, I'll again choose my option of arc. Now I have excess material on this side, so I'll leave this at let's say 5mm value for lead-in of the arc. In other words, 5mm from here to here. And my lead-out, I'll use the same as I've done in my lead-in. I'll simply choose now save and calculate. And if I do my simulation again using the solid verify simulation, you'll note my tool will go in, mill around the entire part, and then finish the part itself. Now you'll note that there may be something like a little material left at the very bottom. What I can simply do to take care of that is simply go into my levels area and add a little delta depth. Say I want to go down an extra millimeter. If I do save and calculate and simulate now, you'll note that my tool now went further down on the part itself. I'll end my simulation and now exit. Now I'm ready for my next operation. In my next operation, I like to mill out these areas over here. And I have 4 such areas on this particular part. 1, 2, 3, and 4. Again, I'll choose my operation, add operation profile. This time, my profile will be 4 open geometries. My first one will be over here. And I'll accept that by simply clicking on the V over here. My next one will be here. My third one over here. And last but not least, my fourth one will be on this side over here. Now we have 4 chains, and all of them are open. I'll choose a tool, and the tool that I will be using in this particular case will be an 8mm end mill. The reason why I've chosen 8mm end mill for this particular case is because my radiuses on the part over here is 5mm. So by using a tool, it's a diameter of 8mm, I'll get a radius of 4mm on the tool, which will work a lot nicer in those corners. My levels, my upper level will be this step over here, and my lower level in this particular case will be down to over there, which will be a total of 3mm going down. My technology area, I'll be using left with compensation. I'll be going one way. Now, by using an 8mm tool, although it's good for this particular corner over here, it may not cover this entire area over here. So again, when I do my rough and finish, I will again use a clear offset. Now my wall offset, I'll leave 0.3mm for the finish. And my clear offset, I'll say, okay, let's start 5mm away, go in a total of 4.7mm. Now when we go into my link area, again, I'll choose the option of going with an arc, and this time I'll leave it at 2mm, and my lead out will be the same as my lead in. Now when I click on Save and Calculate, you'll note that the tool will go down, clear the area, and then finish it. And it'll do the same thing on all sides. Show you the simulation from the very beginning, simply by clicking on Operations, let it run all the way through. We first have that our face, our second step, and all has been finished. You can see everything done in our simulation over here. Now my next operations, I'd like to do it on the flip side of this part. And I'd like to start again with a face mill going over here. I'll simply go into Operations, Add Operations, Face. And this time, I'll go into my coordinate system and choose my second coordinate system of the part. As you'll note, the part automatically flipped over to my second coordinate system. I'll choose my geometry, and again I'll use my geometry as the entire model, as you see here. And we've chosen this face, and now we're, as you can see, again we have the boundary around the part. Again, I'll choose my tool of 20mm. My upper level, I'll have it as 2mm for excess material, and my face depth will be over here. My technology, again, I'll be using the hatch, but this time, just to show you the difference in what control we have, I'll use my absolute angle as 90 degrees. So that the tool will actually go 90 degrees across the part instead of 0 degrees. I'll leave my extension exactly the way it is, my cross exactly the way it is, no changes. I'll be working zigzag with a fillet at the end. And I'll leave my overlap at 30%. Simply go into Save and Calculate. And if I do my simulation now, you'll note, again, if I use my top view, one step at a time, my tool comes this time from the upside over here, working 90 degrees on the part itself. In my next operation, I'd like to now mill out the pocket that we see over here. Now you'll note that this pocket has islands in it also, but the island only start from a certain depth. So what I'd like to do in this particular part is first mill out a pocket from the upper level over here up until the depth, the height of this particular island, and then do another pocket operation from this height over here of the island all the way down to the floor, and then including the operation of the islands. I'll start my operation by adding operation of pocket. And since my last operation I was working in Mac 2, it remembers this position until I change it to something else. And this is the position I want to work in right now. So I'll simply continue on to define. And my geometry will be from this line, auto constant Z, and that's my entire geometry right now. The entire top part over here. I will not include my islands here since I'm working from the top of the part only up till the height, that very top of those islands itself. Now the tool that I will be using will be my tool number 2, 16mm end mill. My levels, my upper level will be from the very top of this part, and the pocket depth will be up until the step itself, the very top of the step. The technology, we have different types of technology in working in pockets, such as hatch or contour. In this particular case, I like to work in contour. I will leave my overlap between tool passes as 65%. My wall offset, I'll put it at 0.2 millimeters, and the same thing with my floor offset. My island offset I do not have to set since I do not have any islands in this particular operation. Let's continue on down now to our link area. And in our link area we have different ways of ramping into the part. We can ramp either vertically, going straight down at a specific angle, or in this particular case I would prefer working in a helical motion going down. And if I'll choose my data area, I'll choose an angle of, let's say, 20 degrees as my helical angle and a radius of 4.8. If I continue on down, I have my lead out. My lead out I'll leave as an arc of 2 millimeters, and I'll simply say save and calculate. The result is, if I were to go into my solid verify, I'll do this a little slower. My tool goes down in a helical and mills out whatever it was able to mill out in that pocket up until the step itself. I'll now exit, and now the next operation I'd like to do will be milling another rough cut from this step over here all the way down to the floor. We'll start by choosing a new operation, again pocket, making sure I'm with Mac 2, and this time when I defined, I want to take 3 boundaries: my outside boundary, the boundary of these 2 pockets that within. Now the rule is that when you're having an island on a part, the outside boundary is always the first boundaries, and the islands are always the boundaries that are following it, second and third. In this particular case, I have a quick way of choosing my boundaries by doing what they call multi-chain. If I were to go into multi-chain and click on add, all I have to do now is simply click on that floor, and every single geometry that's on that floor would automatically be picked up. If I were to accept this, you'll note that 3 chains were automatically created, whereas my first one being my outside chain around the outside of the pocket. I'll simply accept this, and now I will choose my tool, and the tool, again, I'll be using the exact same tool as I've used before. In my levels area, my upper level in this particular case will be the top of this island over here. And my pocket depth will be up until the floor itself. In my technology area, this time I'll have 0.2 on the floor, the wall, and the island as well. The link, again, I will use the helical link with an angle of 7 degrees this time. And my lead out, again, I will use the arc. Now, note when I do save and calculate and simulate, the part is being machined inside. However, there are areas where it could not go into, and this is very simply because the tool was too big to go into those areas. But I've decided to use a bigger tool in any case to take out as much material as possible. Therefore, my next operation, I will do what they call save and copy, creating a new operation, as we can see here, based on the old operation. Just make some changes now in this particular operation. For example, I will use now a smaller tool. I will use my tool number 4, which is a 6mm end mill. The levels I'll keep the same as I've done before. In my technology field, I will use now something new called rest material chamfer. With rest material, I can tell it I want it to go into rest area, which means I only want it to work in those areas where that previous tool could not go into. In my data area, we'll be working on separate areas. Around profile, I will talk about later on. And in my previous tool diameter, I can either write what my tool diameter was or simply press on previous tool diameter, and I'll have my list of tools that I've used before, and simply click on the tool that I want to use. My previous wall offset will be 0.2 millimeters. And now my extension overlap, I'll set that at 1 millimeter. What this does is very simple, is that right now I'll be cleaning in the area where the previous tool did not. But I would want it to start a specific distance away from where that area could not clean, so as to not avoid having a mark on the part itself. I'll simply say OK. In my link area now, I will use a lead in, something I could not do before. But now that my material has been cleared away, I can use a regular lead in of an arc, and my lead out will also be of an arc. Now if I do save and calculate and simulate, you'll note that the tool, I'll slow this down a bit, will go down and only work in those areas. Let's take away the tool holder so we can see what's going on, and I'll do it again. It's only working in the areas where the previous tool could not work, on those corners and inside this area over here. In my next operation, I'd like to finish off the walls of this particular pocket here. I'll simply do that by going to my operations, and this time I will use a profile operation. Now, using a profile operation, if I want, I can use the geometry that I created for my very first pocket, which was working only up the geometry being the border of this wall itself only, without the islands. That would be contour 3. So I'll choose contour 3. If I want, I could show it just to make sure I'm using the right geometry. The tool that I will be using will be tool number 4, my 6mm end mill. My levels will be my upper level from very top, and my profile depth will be at the very bottom. Now my technology, I'll be working on finish only, and in my link area I have my lead in of arc, and I'll have the same thing with my lead out. If I have to do save and calculate and simulate right now, you'll note that my tool is going down, close to the corner, and continuing its operation cleaning around. Let's take a look at the Solid Verify. Again, my tool will go down. Let's get rid of the tool holder, go around, and then retract. Now, sometimes you may say to yourself, you know what, I really don't want to start in this corner over here. I want to start at a different point. I want to start, let's say, at this point over here. This can simply be done by going to my technology area into Modified Geometry. In Modified Geometry, I simply click on the chain and say, OK, define start. If I click into that window, all I have to do is click in the area where I want to have my start point, accept it, and just simply save and calculate. Now when I do my simulation, you'll note that the tool will go down and it entered at that point over there, and now it's simply working its way around, finishing the wall of that particular part. Now in my next operation, I'd like to finish off the walls of the island itself. What I'll do is I'll simply go into this particular operation that I've done before, and I'll say copy and then say paste, creating a new operation, and then just change some of the details. For example, I'll change the geometry that I've used. In this particular case, I'll change it to contour 4. But contour 4 is not really good because contour 4, as you can see, includes the outside geometry, which is I do not need that right now. So what I'll simply do is this. I'll create a new geometry. And in this geometry, I'll take this edge over here, reverse it, and say automatic constant Z. And I'll do the same thing with this geometry over here, with this side over here. Again, also reverse the direction and auto constant Z. As you can see now, I have a new geometry just on the islands. Now, in my levels, my upper level in this case will be over here, and my profile depth will be up until the floor over there. I'll leave my technology exactly the way it was for my previous operation, and my links, I'll also leave it exactly the way it was. Let's just do a simple save and calculate, simulate. If I do the Solid Verify simulation, you'll see that the tool will go down, machine around that island, and the same thing with that one over there. Now, my next operation, I like to finish off the very top of the island himself. I can, if I want, I can use face mill, but I can actually, if I want, I can even use a simple profile operation to clear this off also. If I were to start a new operation, in fact, I'll take this particular operation that I've done before and simply do copy and paste. And again, I'll go in here and make some changes, such as the tool. This time I'll use a tool number 3, which is an 8mm in diameter tool. My levels. My upper level will be here. And my lower level, my profile depth, will be the exact same depth as my upper level. My technology field, instead of using left, this time I'll use middle. This way the tool will actually be on the middle of the geometry I've created and go around the middle of it, thereby covering the entire part. I'll be using my finish technology, but in this particular case all I need is really rough, and I'll leave my floor offset at 0. Since it's working on the middle, there is no wall offset. My link, I'll leave it as an arc. Simply do save and calculate and simulate. You'll note that the tool, when it goes into the part itself, will go down, leave it an arc, and the same thing with the other island itself also. Again, cleaning both of the tops of each one of these islands. Now in this operation, I'd like to finish off now the floor of the part. What I want to take care of when I do finish the floor is that I want to stay away from the walls itself on this operation, since I've already finished the walls. I'll start my operation using my pocket operation. I'll use the geometry contour 4, which includes both walls and the island, because I want to work around those areas. The tool, I'll be using tool number 4, my 6mm end mill. And my levels, my upper level will be the floor itself, and my pocket depth would also be the floor. In other words, I'm going directly to my floor. In my technology area, in order to stay away from the walls and the floor, I'll simply put a small offset on the wall and on the island. The floor I'll leave at 0 because I want to finish the floor. My link area, I'll just change my lead out to be an arc, and I'll simply do save and calculate. Now when I do my simulation, you'll note that my entire floor was done. Let's do the simulation a little slower, and I'll get rid of the tool itself, the tool holder itself, and as you can see, the entire floor is being milled out. Now that I've finished milling out this pocket over here, I like to concentrate on this slot. Now if I measure this slot, you'll note that the width of this slot is 1.5 millimeters. So I'll simply take a 1.5 millimeter end mill and work on this particular slot over there. I'll simply start a new operation, and I'll use the slot option. Again, I'll be using Mach 2 position 1, and my geometry, I'll start off with this line over here and simply choose Auto Constant Z. Now you'll note with the position of the arrow that I would want to work on the left hand side of this particular slot. Now I will choose a tool. Like I said, I'll be using a tool that is 1.5 millimeters. My levels, my upper level will be over here. And when I go into my technology area, we have what they call constant, which is exactly what I want to do here, or section, if I want to work on a specific section cut. When I work on constant, if I go into the data area, I can say again, if I want to work in the middle, in this particular case, as you've seen before, as I've pointed out before, I want to work on the left-hand side of the geometry. I can work with or without compensation, one way or zigzag in this particular case one way. My depth in this particular case will be up until the floor of the slot itself. A total of 1.5 millimeters. My step down, I can go down every 0.8 millimeters. Simply say OK. Save and calculate. Now when I do the simulation, you'll note that the tool will go down and mill out the slot exactly the way I wanted it. Let's do it a little slower. And I'll get rid of my tool holder. Tool goes down and mills around the slot itself. Now what we have left to do on this part are drilling out these holes. Now you'll note there are two different types of holes that have to be done. We have the through hole over here in 4 spots, which is of a diameter of 5 millimeters. In addition, we also have these holes over here, which are tapped holes of M2 by 0.4. Not your standard tap, but it's 0.4. Our first operation of drilling, by drilling these 4 holes over there, by simply going into operation, add operation, and we'll go into the option of drilling. Now when I choose drilling, I'll go into define, and by simply clicking on the face where the holes are located, it will automatically pick up all the holes that are on that particular face. I'll simply accept this. Now the tool that I will start using will be a 6 millimeter 90-degree tool, or a spot face drill. Spot drill. My levels, my upper level will be this floor over here. Now my drill depth, instead of calculating how deep to go, because I want to have a little bit of a chamfer on the edge, I'll simply say my drill depth will be also 0. But what I will tell it to do now is that I want the diameter value of the tool to get to 0. The diameter value that I want of the tool to get to 0 will be 5.5, giving me a 2.5 millimeter chamfer on the edge of that particular hole. My technology area, I use simple drilling option. If I were to open this up, you'll note there are many options I can use, but I simply want to go drilling, not peck. Save and calculate. Now I'll continue on from this point to my next operation simply by doing save and copy. And in my next operation, I'll go into my tools, simply change the tool to a 5 millimeter drill. This time my upper level will be the same, but my drill depth will be to the very bottom. Obviously, I have to go past the bottom. So what I'll do is in my levels area, I'll use what they call full diameter. Notice I want the full diameter of the tool to get to the bottom. If I want, I can even go a touch deeper than that. And I can say over here -1. And all of a sudden the tool will even go past that area by 1 millimeter. Again, I'll do save and calculate. Now let's do our simulation, and I'll simulate this time both of these operations. If I go into Solid Verify, my first operation was my center drill, and now my second operation, I'll do it one at a time. Drills out the holes themselves, and you'll note that there's a chamfer left at the edge of each one of these holes. I'll leave my simulation now and start with my second drilling operation for these tapped holes over here. Start my next operation again by going into drilling. Again, my position. This time when I choose my geometry, I'll click on this face over here and on this face over there. The tool I'll be using again will be my spot drill of 6 millimeters. My levels, my upper level will be over here. But this time, instead of using my diameter value, I can also use a simple cutter tip option where the depth will be exactly what I tell it to go down to, and I'll tell it to go down exactly 1 millimeter. I'll simply do save and calculate and go to my next operation. Now my next operation, I'll change my tool to a 1.6 millimeter drill. In my levels area, this time I drill depth. If I go to the part itself, I can actually really get close and simply click on the point at the bottom. In my technology area, if I want now, if I can use PEC instead of straight drilling. And in my PEC area, I can tell it that every step down should be, say, no more than 2 millimeters. Simply save and calculate. Again, save and copy to go to my next operation. Change my tool. Now I'd like to use a tap. Since I do not have one created yet, I can simply go and add a tap from my field, and I'll be using a thread diameter of 2 millimeters with a tip diameter of, say, 1 millimeter, and my pitch, mustn't forget our pitch, I said was 0.4 millimeters. My levels, my upper level will stay the same. My drill depth, however, I'm going to change it to go down only up until that area over there. If I want in my delta depth, I can say 0.2, having going 0.2 millimeters above that point over there. In my technology area, you'll note that since I've chosen a tap tool, it'll automatically put the drill cycle type as tapping. Even if I click on it, you'll see the only thing that's available now is just tapping. All I have to do now is save and calculate, and then we're done. I can zoom out. And let's just do now the simulation of these last 3 operations. Simply click on Simulate, Solid Verify. My first operation, my second one, and my third one. And now we've completed our part. Obviously, after completing a part, we always have to go into operations and simply create a G-code by simply going to G-code all and generating a G-code for our part. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.